everyone. I welcome all of you to the second session of the day. And today we have with us Vidhi. Uh, she is working as a staff data scientist at Walmart Labs. She has given lots of talks at various international forums, and she has been awarded as the AI Changemaker of 2022. So she will be speaking on how AI can be used for cybersecurity today. Over to you, Vidhi.
Hi, thanks. Is my screen visible, I hope, right?
Yes, it's visible.
Okay, great. Welcome, everyone. I hope you're having a great time listening to the experts and Walmarts. Um, so today I'm going to discuss about the conundrum of AI and cybersecurity. The agenda for the talk today is I'll briefly set the context of cybersecurity and the state it is in today, and then I'll slowly take you to how AI plays a role in cybersecurity, what are the adversarial attacks. I'll take you through one of the examples, and towards the end of the talk, I'll give counter adversarial solutions. So what are the solutions which we can use? And it's a very thorough research area today in the space of AI. So without further ado, I'll get started. To make sure that the context that I use and the words that I'm going to use for rest of the talk, we are all on the same page. I'll explain a brief on cybersecurity and what all terms come under this umbrella. So basically, cybersecurity is to make sure that all the computing systems that we use, the gadgets, the devices, we are able to secure them from the hackers and attacks. So it could involve software, hardware, intellectual data, and loss of information, basically. So the cyber attacks involve malware, ransomware, spoofing, phishing, sabotaging of vital information. So basically, your credentials can get stolen, your account can get taken over, and the privacy can get exploited. From the organizational point of view, if we have to look, data is new oil. So data is everywhere. The networks are increasing vastly, and so is the data. After a point, it's becoming actually very overwhelming to manage data and at this scale. So whenever a breach happens, it takes an organization a lot of money and resources in terms of time as well to overcome that breach and leave aside the kind of litigation that the organization has to go through later and the sense of responsibility that it is coming under attack. So when these kind of incidents happen, the organization find it very imperative to build secure systems which they can rather use the money as a prognostic measure rather than letting that money basically go into a crime, letting a crime happen and then later on working on it in a diagnostic mode. So what happens is these cyber crimes, we can say that when we have seen them time and again, why do they still get undetected? So they get undetected because they're coming through various forums. It can come through various browsers and through private networks, which can easily get escaped through the current systems. So organization, they find it important to build a robust system which do not let these kind of crimes peep through. So we'll first discuss on where we are today, what are some of the practices that have been followed today, and how and when AI comes into the picture. So as a thumb rule, the yellows are the ones which exist, and greens, to a certain extent, they exist, and these are the offerings which AI can bring. So traditional indicators, there are various indicators, characteristics, and signature-based techniques. Whenever we talk about ML, we want some, ML can only be applied to the cases where we have data which supports pattern. So basically, it has to carry a certain characteristics. So those characteristics, when we are saying are existing in the current system, they can only work well against the known threats. So whatever I've seen before, my system got compromised. My current set of parameters, they can only work well against those. What I want to, however, bring is a system which can learn from human experts and at least give a baseline that is at par with what a IT security analyst can do. Now you would be thinking that we are talking about AI and still we are kind of compromising on the offerings of AI. We are still saying that it can give a baseline. Yes, and that sounds very tedious. That initially it's always good to start with a baseline and see if it can at least let some of the IT experts bandwidth go free into handling more critical tasks. And I'll explain in the coming points how it is very important. So next is the regional spread and the manual tracking. So the IT security experts, they are working round the clock, and the devices that they need to handle and the kind of network they need to take control of are spread across geographies. So the regional spread makes it difficult and overwhelming for them to handle a large scale of incidents. And not only this, the response is not that fast that is needed, and it makes it difficult to handle all kind of uh, issues. So when I mentioned in the above point that we can have at least one system which can let AI learn from the experts and give a par performance, not exceed. It can at least give a par performance at whatever it has been seen so far. At least it can help and detect those. That's where the second point comes, that it's an 80-20 principle that you would have heard mostly, where if 80% of the load can be taken off from the IT teams, and we can rank order them basically. So this is commonly known as exception ranking. What is exception is when you expected a certain behavior and it didn't go as planned. So you make sure that when you build a system, a security assisted system, it is robust enough. It is able to keep you safeguarded against these previously seen breaches. So when those kind of exceptions, when those expected behaviors are not handled, because the hackers and the bad actors, so to say, they are constantly evolving. So when something unexpected happens, this is known as exceptions. And in the AI language, this is exception ranking. In a rank order, I want all those exceptions based on the criticality index. If they're rank ordered, the person who, or a planner or an expert who is sitting and watching those exceptions ranked in front of them knows which one to handle first. This is at least those 80% of the cases which AI can handle and take off the load and let the IT experts handle more critical incidents, thereby freeing their bandwidth and resources. Another way I can put it is that it leads to efficient resource allocation and application of best practices. You can think of it as a trade-off and an analysis on what is my IT inventory vis-a-vis what is the threat exposure and which one I need to give more importance to. Next is a diagnostic versus prognostic approach. So if something has happened and I'm just constantly stifling around, seeing how to bring back my system and how to make it secure again, I am basically letting everything bad happen and then I'm acting in a control mode. So I'm damage control mode. So if those threats have been handled before, if those threats would have been predicted before, somebody would have taken a timely action based on the alerts and would have responded and done some bit of a remediation. So that's where AI also helps, because it's not just learning once. The data it has is not just learning once. It has a tendency of being ever learning, dynamic. It learns through billions of data artifacts to be on top of what are the new possible threats that can occur, and constantly evolves. So that's where the prognosis impact of AI comes into the picture, which acts as a safeguard to the possible threats that can come in the future. So it again takes us back to the point that the traditional indicators which are working against the known threats, it can happen that you're having a latest security patch, you would like to get updated, but these need to happen at such a pace, and the bad actors are correspondingly working at a greater speed. So if those are, there is a mismatch between the two, you are totally exposed. Your system is totally exposed. Additionally, what can come with AI in cybersecurity is it lets you do the user profiling, entity profiling. I can say largely the term is entity profiling. It can help you do the profiling of the endpoints, the applications, the kind of servers which are mostly exposed. And what it lets you do is build a baseline profile of all these entities. Now, once I have a baseline profile, and yes, this baseline profile also keeps evolving. I'll explain how. But if you have one, for example, baseline to compare with, and next what you monitor is something which is a deviation on that behavior, you can quickly identify what is the anomaly here and can totally take down that possible attack. What else it can do is it can guide you and route you to what is the most likely next place that you would get compromised with, and you can accordingly do the resource allocation towards the uh, area where you are going to be most vulnerable. The impact is going to be high. At those particular places, you can route those resources. That's where efficient resource allocation again comes into the picture. Additionally, it helps you look after your hardware, the data centers that you maintain, the parameters like backup power, the consumptions, the temperature, the cooling filters. If all of these are monitored and observed, you basically after a certain period when you're analyzing, you get to a point where you know that these are the normal range of values in which these parameters work. And next, what it helps you do is do the predictive maintenance. So once that happens, it doesn't let your data centers go down, and it gives you timely intervention period during which you can have a backup. So what happens is conventional techniques that we're using, they are better on detection because they've seen those threats time and again, and they're dedicatedly working on escaping those. What AI does is it gives you timely alerts. And yes, when AI happens, there are a lot of false positives that can come. What I mean by false positives is you might get an alert which says that it's going to be a breach. You allocate your resources acting on it, but it later turns out to be a false alarm. So is that a big downside of AI? Again, depends on the trade-off. I can say that I can still allocate some of the resources that might end up going waste, acting on false positives, then letting a breach happen and go through just because I didn't use AI. So what is a win-win for us is if you want to build a resilient system, we can have a better detection rate, and better detection rate can happen when I'm using a combination of conventional, traditional signature style techniques along with AI, and that helps reduce the false alarms with a wider coverage. Okay, so if everything is good, we don't need to bother about anything else. It's a hunky-dory. There is no free lunch though. And what else then we need to pay attention to? So building a AI-assisted cybersecurity system needs a lot of resources. It asks for financial investments in terms of at least bringing up that kind of compute power and time. Then the most critical thing in building an AI-assisted system, be it in any domain, is that it asks for the training data, and it can do only that much good to you as the kind of good training data that you have supplied it to. Then what is the problem? The problem is that are we maintaining that kind of corpus? Are we sitting on that kind of corpus which we can use to build a cybersecurity assisted solution? All the set of malware codes, non-malicious, anomalies that we have seen in the real world, are we maintaining a record of those? Are those correctly labeled? Have we shown machine all kind of examples? And the setting up the data process in itself is very time consuming. It could be totally possible that most of the organizations might not be having those processes already set, and allocating the time and resources to build up those from scratch up is very pocket expensive. Next is false positives, which we have already discussed, and there are a lot of algorithms with which we can handle and tackle and kind of bring them down to a certain number. Definitely those cannot be eliminated because we are talking about AI ML solutions which are probabilistic in nature. So these kind of errors are bound to happen, but there are ways that we can handle them best. Now what happens is if attackers are using AI themselves, so they're hackers, if we are building a solution to save ourselves from the bad actors, it could totally be possible that they're already aware of what are the AI-enabled security tools, and they're keeping themselves immune from us. So then there is no extra benefit that AI brings, right? Next is that what if, despite all the safeguards that we have taken, cyber criminals, they are using AI to launch the advanced attacks. Now this becomes a little interesting in the sense that our security analysts are using AI to protect us from and protect and immune us from cyber attacks. And then on the other side are the criminals who are using it, and now they don't need human assistance. So if we are using AI, which can run on an auto mode to protect us, they can also use AI to run an auto mode to attack us. And then it's about who wins towards the end of it. And I'll talk more about it in the coming slides. Okay, so what are the challenges? We've discussed some before that we need to be aware of. There are some challenges that come with it. Do we have the right data? And what I mean with right data, I didn't explain before, and that's where I'm going to talk here now, is that data is coming from multiple sources. There are multiple entities, like I mentioned, that we need to do the profiling of user, system, endpoints, and all. And it's coming from multiple places. Do I have a systematic way of integrating the data, bringing it all together? So for training data, everyone knows that the data preparation is the hefty work. That's the key groundwork that a data scientist needs to do. Do we have that kind of practice put in place in which we can prepare the training data? Do we have the correct problem statement formulation itself in the first place? Are we clear about how we want to frame it as a problem solution? Using automation for detection as well as response. That is where it becomes a little complex. Getting detected, like I mentioned in the previous slide, is exceptions ranking. So if somebody can sort it for you, that these are the orders in which you need to handle those tickets, response, or problems or incidents that somebody has raised, right? Now what? Somebody has to actually act on it. Somebody has to respond it. So I know something I need to pick up on, but for that response, if it is stuck, then that becomes a bottleneck. And the scale at which we are dealing with the problems, it again remains the problem for us. Nobody is able to handle that scale again, even if it is sorted out for us. Next, what happens is, can we use AI for human assistance? So if we are, for 80%, some problems are very redundant. We are getting timely alerts, and those we are making sure that they are thrown out of the system by a regular checkup. So somebody knows that this is a typical behavior of this incident, and AI is probably best at handling them because it's a repeated pattern. Now, those 20% which are very critical, though we are using AI for it, are we letting AI to take the final response call on it? Are we letting AI to act on it? Maybe not, because of the criticality index, the impact of that incident. And that's where we can say that we are still using AI, but are letting it assist humans, not letting them take the decision on those 20% of the critical cases. So AI can still be used, but can act as an assistant to a human expert. Next is, who knows the AI security system better? That is where the person who knows the security system better through AI wins the game. So there is a hacker and there is a security team. And as you build the system, you get, so conventionally we have a traditional system, and because there are some shortcomings to it, we think that when we bring AI into the picture, it can solve all the problems, which generally doesn't happen because there's a cascading effect. You bring something else into the picture, and there is a set of vulnerabilities that come along with that. So AI in itself brings along some vulnerabilities, something which is who knows those vulnerabilities better gets to win the game. If hacker knows how to crack through AI security solutions and still make a breach, that hacker wins. And if security team is constantly able to keep themselves updated by making the better advanced AI systems, then they win the game. Then they are able to protect their organization and the network that they're dealing with. So in that case, for that AI system, there are new anomalies that you need to constantly be aware of, monitor, because there are anomalies which look like a normal thing and can easily escape through AI as well, and definitely through human eyes. There are new kind of cyber attacks and the prevention strategies that the cybersecurity teams are developing. Obviously, these things are also known to the other side of the world, which is the hacker world, the attacker world. And when both are aware of what are happening in this space, they are kind of constantly devising a better strategy to win over the other. So finally, like we mentioned, we have arrived at a conclusion on AI-assisted cybersecurity, where we know AI can definitely increase the performance and the scale at which IT security teams are handling the incidents. Their efficiency takes a shot. There are vast number of attacks that happen. What we can do is to make sure that the attack surface gets reduced. Attack surface is what kind of myriad problems that you face. Some problems which are very commonly known, conventional and traditionally handled well, can be flagged early on by AI, and that's where human bandwidth gets restored. AI can minimize the breach risk by routing them to the threat identification points. Wherever your attention is mostly needed, you can simply tackle those first and can be prioritized for you. So the incident response time increases, the remediation time decreases. Next is prognosis, where you can proactively monitor it. Even the minutest change in the behavior before it even makes it through your system is detected and taken care of. So everything looked great until last slide. There's one interesting thing, although. So I've worked in supply chain, and in supply chain, there was this term which was introduced as autonomous supply chain. Same as what is here in cybersecurity world, which is autonomous AI for cybersecurity. And what we mean by autonomous is that whatever machine we are building, that machine is now on its own. We are basically giving machine all that it needs to keep itself self-regulated. So once you bring the system up, now the system on itself is responsible for keeping itself updated. Basically, it is definitely assisted by human intelligence, which is all the domain expertise that it needs. It is routed and sourced through the right set of knowledge, which is needed to keep itself evolving and stay updated, which is what we are talking about, the scale at which humans cannot. We just simply cannot fathom that much of information, the billions of data points, the new technologies that are coming, deriving patterns and statistical associations from that data, and still be able to detect the minuteness of it. That's where AI wins the game. If AI is now compromised, then what happens? Like, we as humans are resorting to AI and believe that now there is an autonomous system that is acting, and it is, once we have brought it up, it's been trained, it's been routed through what all new things are happening around, what it needs to be aware of, what all possible breaches elsewhere might have happened, and now I have to be watchful of it, and everything is running on its own. But then how would I trust that system, and how would I even get to know if that autonomous system that I've brought up is going haywire? It's been compromised and I won't get to know. So there's one solution, one possible example that I've seen is from Microsoft. It's a Windows Defender Threat Protection Service. This one of the example, and there are multiple other examples that will come towards the end of the talk. And that is that there are different, when you train a model, when you raise a system, you just don't rely on one algorithm or one data set or a set of features, right? So you have different training data sets and features on which you pick an algorithm, and similar such algorithms are there. So basically, you know that it's a horizontal and vertical solutions that you're offering. Even if one algorithm gets hacked, the rest will continue to behave as they were expected to, under the assumption definitely that they also are not sabotaged. Then if they are continuing to behave, then they would be able to flag the anomaly. So basically, one is kind of tracing the anomalous behavior of other and is able to flag the system that even an auto running AI system is not working as expected, and then calls the need for intervention. There is one very prevalent quote that I've heard from the anti-abuse research team's head from Google, that's Ellie, where it says that before, when we were in a world where more data we had, the problems, more problems came with it. But with deep learning, because the more data you have, the better it is, and that helps you build that autonomous system actually. So we are done with the role of AI in cybersecurity. Now, what is the conundrum here? We believe that AI on its own can solve all the problems, but who is going to solve AI's problem? So that's where adversarial AI, that's the next part of this talk. So adversarial AI, what is it? So what happens is you're having a machine learning model. The adversarial attack on your ML model leads you to give a wrong, incorrect prediction. So what it does is it lets you misinterpret your ML algorithm actually misinterprets the way the input has been given to it, and is bound to behave in a way which is favorable to the attacker. The attacker is that adversarial here who is making the changes in your ML ecosystem, and that ecosystem gets affected and starts behaving at the mercy of how the adversarial attacker is leading it to. What is so granular about it is, for example, I'll just give you an example. This is the prediction of your algorithm. When in the data, you introduce noise. That noise, along with the original prediction, it gets flipped, and now it is giving a prediction of 99.3% is something else. So the panda gets to gibbon. What happens here is this noise is not visible to human. So it's imperceptible to us. But the way the output changes, it changes with a high degree of confidence that it moves past the analysis, that somebody would look at the false positives and false negatives based on the threshold and would see where the wrong predictions are coming from. It moves past that analysis point. So I'll just explain through this flow as well. So you have a training data and that goes into the algorithm, the learning stage, and you have a labels corresponding to it. And based on the ID assumption that your test data is also drawn from training data distribution. So this is the critical part of ML algorithm, that your training and test data have to be drawn from a similar distribution. There should be characteristically same. And when I use the test data, it doesn't go as is to the ML algorithm for the inference. There are some noises introduced. And when those noisy inference input goes into the algorithm, the learned algorithm, the output that comes out of it is compromised. And what kind of compromise are we talking about here? What actually compromise means is it could be targeted or untargeted. In targeted, I as in the attacker here, see, so the attacker can say that the way I'm making the changes, the class y is the class which the adversarial wants to be outputted. For example, if somebody is applying for a loan, and based on whatever this test data would have been, like if your ML model has gone into production and you supply a particular instance for whether the loan should be approved or not, if the test data goes through this adversarial change and makes your way through the machine learning algorithm, the adversarial might have changed the location, assuming that the location or the origin of the country for that person who is applying for the loan is risk prone, and that, for example, acts as one of the key attributing factors due to which the loan application might get rejected. Based on that presumption, if the change that has been introduced here is actually change of location, which gets unnoticed, then I am forcing it to go to a particular class. So if the class would have been do not approve the loan, then the target is to make sure I am able to make the change into the input data given to the trained algorithm, right? So that it outputs the class of my interest. It lets me pass through the system and forces the algorithm to give an incorrect prediction of approving the loan for the attacker. Or it could be untargeted. I don't have any intention to give it to a particular class, but I definitely want to make sure that it doesn't give the class which is the original class. For example, it's a multi-class problem. My focus is to just change the input in such a way that it just flips the prediction no matter which particular class it might go to, right? Okay. So what are the types of attacks? I'm just listing down few here, and there's a thorough research being done here. So one is poisoning, another is evasion, and the third is model stealing. There are some differences, minute differences among the three. So just stay along with me and I'll explain how it is happening. In poisoning, basically you are poisoning your training data, the data on which your algorithm is trained, some samples of it, basically some labels which I wanted to be which are of my particular interest. I want them to be flipped in the inference. Hence, I'm changing those in training time. So what happens is during training time, those particular samples, which when I want to show in the prediction time, should give me a prediction of my interest. I go back and change those into the training data, because the algorithm during the training time has seen those specific instances been given a particular label. For example, they should have been given as a fraud label, but because the attacker changed them to not a fraud label, for example, then those malicious samples, they train your algorithm in such a way that the output goes in favor of the attacker. Now you would be wondering why I've made this particular part in bold. Then most of us would be thinking that when we do training, we look thoroughly at the data and we make sure that these kind of loopholes are not there in the system, that somebody can come and make changes into the system, right? And your data changes all of a sudden, and now you are giving some output prediction which is in favor of some random person out there. So definitely training is, in most of the systems, definitely it could be training is one time and you are not exposing it to those bad actors. But wherever these trainings, most of the time in the ML algorithms, the trainings are not one time based on the dynamics of your environment with which your ML algorithm is dealing. A lot of retraining happens based on data drift, concept drift, and there are a lot of signals that your algorithm receives based on which it needs to retrain. And when during that retraining time also, those labels, those data samples have been made contaminated, the labels or the outputs would be again in favor of the bad actors. So that is poisoning of the input data on which the training is happening. So the training data basically. Next would come a place where the inference, the time at which it has gone to production and I'm trying to infer, that data has been contaminated, and that is evasion. So evasion is when you are trying to evade getting detected. For example, the one that I shared before is when you are trying to hide your country of origin. So it doesn't have an influence on your training data, but definitely on the inference data. The model itself is what you're targeting. That model was supposed to give a particular prediction on which it was rightly trained, but because the data is supplied to it, I knew that how I can flaw my input data in the inference, that I can force my model, I can target my model to give a particular prediction which is of my interest. Image-based spam, for example, is one of the ways it can happen, is that there are certain pixels. So basically, this evasion happens a lot in image-based examples, the use cases which are based on images. And why specifically images is because images have certain pixels which are significantly associated with the target variable. And when the bad actor tweaks around those specific pixels, first of all, it's identification of those pixels. When somebody tweaks around those, it leads to the prediction flipping. Prediction flipping is something that it's supposed to give rightly that gets flipped around, and that small change in that pixel is actually that is unidentified. Is the example that I've shared before also. This particular example, this is basically from evasion, that you're trying to evade because the change is happening on the inference data. So that's the example of it. The last is model stealing. Now you've seen both sides of the data are getting impacted. So what is left is the model itself. So model stealing can also happen, yes, based on how your model is being deployed. Somebody has access to it. There are APIs exposed. Now somebody is trying to pass some input to your model and get some data. And based on that, also a set of association learning is happening. So it is an attempt to reconstruct your model or trying to gather some information or infer some information about your training data, which is the extraction of some confidential data during the training time supplied to the model, which can be extensively misused. And this mostly happens in proprietary algorithm. What one needs to be aware of is that if there is something which is very specific to your model, and there are certain features on which your algorithm is very sensitive about, and if that kind of sensitivity analysis is being gauged by bad actor, it's very easy for them to act on that particular attribute and be able to still reconstruct your model to a large extent. Information loss definitely would be there, but they would still be able to make through your model. Okay, so I'll take one example of training level attack. Yeah. So we have talked about inference attack, which was the pandas example, and this is during the training time. So this is the training data which goes through model learning stage, and there's a learned association on which when you supply the input data, you get the correct set of labels. And minded, there is no acting of no manipulation of the data itself. On the other hand, what happens is that in your input data, this is an imperceptible noise being introduced by an attacker, and that changed bits of data now makes through the model and has been forced to give a falsified labels output. So again, the attack strategies can be many. You can manipulate current data or can supply new data also, which is falsely labeled to give a specific output or any output which is other than the actual output, like I shared before, or it can altogether corrupt the logic of your algorithm. So the intent is not to get what I want out of your system. I just want to make sure that your algorithm is not giving what it should be doing. Basically, it gets confused with certain instances having the correct label with it, and similar instances of what are correctly labeled, similar instances of those correctly labeled samples are now being forcefully given a false label, the flipping of the label, and the machine gets confused. There is no signal to extract. There's like a lot of noise, not being able to make sense of what is what, and the entire logic gets corrupted. Okay, so attacks category again is if you get access to the data set, then you are basically inferring some information about the data and are able to make a substitute model, which I was talking about, as you can reconstruct the model or you can poison the data itself. So this is one illustration of adversarial attack. Next is square attack. First, I'll explain why it is called a square attack, because effectively this is mostly on those pixels, like I mentioned, specific pixels of your images have higher sensitivity towards the target. and those pixels are in square form. So if those pixels somebody can change, they can make your actual output go any direction, right? So that's a square attack. It might look little dreary here. I'll just walk through it to make sure that you all are with me. So this is the functional form which we want to learn, and we have d-dimensional inputs, and there are the k possible classes of output that we can have. What our algorithm gives is a particular score between this range, so that if X input, training input, for example, that we are giving, it has a corresponding class label for it. Expectation is that if some X prime comes into this model, takes into this functional form, and the output that it gives a score which belongs to any of those K output classes. Now comes the attacker. Now what attacker's objective is that let me curate and let me iterate as many number of times as possible to create an X vector, a new X vector, a new instance of inference data, which when I'm supplying through the learned model, through K of the classes, it gives me one of the class, but it is not the actual class that it should have outputted. So that's where it's been formulated that X hat should be as close to actual X, so basically it is falling within that epsilon range, that it goes undetected. And that's where a highly confident, so like in Panda's example where we were seeing, the class has been incorrectly labeled due to the adversarial attack at the testing time, at the inference time, but that was not carrying a lesser score, it was having a highly confident score. So even the post analysis of that algorithm, it would have escaped. So the injected image that has been generated from multiple random perturbations. So this is not this X vector, we are not able to achieve it in one go. The attacker tries to do multiple such random perturbations into your model, into your image, sorry, through which they are able to identify where and how it should be changed, so that the change gets unnoticed, and at the same time the output is not what it should have been. So that's a perturbed adversarial example, and that's what I exactly explained, that it forces your output to go to the incorrect class under the minimizing the loss in such a way that the output that would have come from this is as close to this. Okay. So we've come a long way. We've started with current cybersecurity solutions. How and where AI can come into the picture? Should AI assisted cybersecurity be our ultimate goal? Or we can have an autonomous AI in cybersecurity solutions. We have also discussed the challenges that come when you bring AI into the picture. It doesn't come with just the magical wand. It comes with a lot of ifs and buts, and the trade-offs at the organizational level it has to be made. Then we switched the gears and we went to adversarial side of AI, where AI itself is getting impacted and someone has to control and take care of it. And among that, there are multiple ways. Two sides is for the data, the input side and the inference data. Then towards the model itself, if somebody acts on it, and how attacker can again work under a constrained optimization problem and can work out those examples on which machine can be forced to give a wrong output. When everything else has happened, we have arrived to the last leg of our talk, which is counter adversarial solutions. So what are we doing now to protect our AI solution then? So it can be that you are practicing adversarial training, which is very difficult. For example, in the pandas example, if we figured out that some bit of that noise being introduced can make my output go totally in different direction, even if it has come to my notice, what I can do as a data scientist is to make sure that that doesn't happen again. If something has already happened, I can make sure that the future attacks don't happen from learning from that example, right? And that I need to supply to the algorithm. So the problem is that, first of all, identifying those examples is a task, even if they've already happened. And letting them being identified in an auto discovery mode is altogether different. So I don't want to be sitting out here doing those analysis day in, day out, saying that I now need to make my AI robust against these attacks, right? So those auto discovery become a task. And I want to make sure that future attacks should not happen as well. So there are many toolkits and these solutions available, and a lot of companies are working on it. One such that I found is IBM's Adversarial Robustness Toolbox. Do give it a look if it is of your interest. Next is model switching. And that's where actually things get like little similar between these two approaches. And I'll explain how. So in model switching, switch happens. And what we mean by switch is that whenever I have an algorithm which is making a prediction, what I'm forcing my system, ML ecosystem, right, to just keep changing the model. For example, I have multiple models, model 1 to model 2 and to model 3. So basically, whichever model at any time is given prediction in the production environment, it keeps changing. So when I know that I am not able to learn or mimic or imitate any particular model, because the models are themselves also changing in terms of giving the predictions, then for attacker it becomes difficult to gauge all the models at once which are at play and among which the predictions have been switched. So it becomes a problem of learning either one versus all. Like if there are 10 models, learning one, trying to mimic one, and then trying to infuse the malicious behavior in one is still easy versus trying to learn all. So we borrow time, we bring more randomicity, so to say, from our side, so that it becomes difficult from attacker's perspective. And on the similar lines is, can we use multiple models? Because we know that ensembles work best. Can we have multiple such models in which now we are not switching, we are actually taking all maybe n number of models together, and if even if attacker has been able to get into the way of one particular model, the combination of models, like I mentioned in the Microsoft example, maybe the other models which are not yet impacted can monitor the journey or the change in behavior of the model that has gotten contaminated. They can monitor that and kind of still make sure that the AI cybersecurity ecosystem is still robust against the attack of cybercrime. And again, the same principle works here, that same one versus all principle, that you may learn one, you may attack one, but the time it takes is enormous to learn all and attack all, because our models are also constantly evolving. So we've come a full circle here. Like I mentioned during middle of my talk, is that it's the game. AI, if attackers are also using AI, and they also don't use or maybe don't need human intervention to uh, cause crime, to create malicious behavior, then so is the cybersecurity team here. And whoever is working and is able to make those changes strong enough, rapidly enough, dynamically enough, they are going to win in this game. So both are at their play. They are both doing their best. What we are trying to make sure is that we are again a step ahead in which we can foresee what might happen and trying to make sure that it's strong, robust, resilient enough that we can escape those crimes. With this, I've come to the end of the talk. I can take any questions if there.
Yeah, thank you, Vidhi. It was a wonderful talk, and I think much needed talk because AI and cybersecurity both are buzzwords nowadays. I have provided a facility to all the participants. They can unmute themselves and ask questions.
Yeah, sure. And by the time I start receiving questions, if it is of interest to others, towards end of this slide, I have shared the resources and the references that I've used. If needed, I can share those as well. There are a lot of research going around this. If somebody is interested, they can carry on with their research and learn further advancements in this field. Okay, so question is, which AI algorithm provides the number of bits modified in the data? So Pankaj, can you be a little more clear on this? So is it from the attacker side you are saying that how they can identify which bits get modified, or from our side that how to find the sensitivity of bits with respect to the target variable? Solution provider side. Okay, so what I can do is, maybe because I don't have expertise in computer vision domain, I've worked on NLP and conventional ML algorithm side and the graphical models one. For this one, I can go back, check, and maybe share the link. All right. Okay, so if there are any questions that I can take on the top, any topic around that, I'll be happy to answer.
So I can ask one question.
Yeah, sure.
So we deploy AI algorithms, right? So there may be an important issue of bias.
Yes, yes.
So what if algorithms start behaving biasly and it start committing some crimes?
Mhm.
So how those issues will be tackled?
Yeah, sure. So actually, it's a two-stage problem. One is that these kind of bias identification even before deployment also, these kind of bias identifications are checked, and the algorithm has been made robust against. Again, for bias checking, there are a lot of algorithms and techniques and toolkits available. But when it goes into production, then again, it's a two-stage problem. Whether it's I don't believe in any of the organization, any AI algorithm is as of now running on an autonomous mode. We are not there yet that it's kind of biased and it's getting undetected. So same set of approach when which we adopted during the model building stage. That approach again is valid on when the model is in production and is again continuously monitored. There are a lot of drift, like I mentioned, the concept and the bias inflicted drifts as well. And there are a lot of signals that are being induced into the system, which sends the alert, which tells that the model is not behaving as expected. So there is definitely a baseline which is set against which the model is being benchmarked. And if it is not going in that direction, then the model goes into the diagnostic mode again. So between production, first is the building stage, and between production, again, it's a two-stage problem.
Okay, thank you.
You're
If there are
welcome.
any questions,
Hello.
Hi.
So, ma'am, my question was like, since with the topic of AI, there's always been this concern that it'll eventually become self-aware. Is that a valid concern?
Okay, so that's very far from here.
No, no,
I
ma'am. Actually, my
yeah.
question was like the implication of that self-awareness on like security. Like, if we implement AI in security, and if
Mhm.
it becomes self-aware, then it might start doing stuff that it thinks it's right. That was my question.
Okay, so first, Prajal, a very valid question, and it's a very well concern in the AI industry. It's been talked about, like I think 5-10 years ago. Stephen Hawking and many other industry experts have shared these concerns. So one is, first of all, I think it's still maybe an estimate as per last research that I read is we are 8 to 10 years at least far off from here. We are not even, in most of the cases, we are not even making AI do what we want it to do, letting AI be built to that extent where it is doing something on its own, self-aware, having that self-conscientness, so to say, which it can keep acting on its own direction and can cause damage to the humanity, right? So for that, first of all, there are a lot of frameworks which being developed, which are working towards the responsible use of AI. So, and there are a lot of regulations around the countries across the globe which is definitely acting on making sure that technology, and it's definitely not just about AI, it's about any technology that we are working on and something that comes new across the horizon, that it's acting to the best interest of human. That's the primary goal of it. One of the ethical principle that I can share with you is to make sure that it is working towards the comfort of humans, and it's not it comes with its moral implication, so it's not going to damage humans or take a decision which can go against them. So these are some principles which are getting operationalized now, because of which every organization, every product solution provider who has to make such product which can someday do this, they have to go through a lot of interrogations, questions, documentations, and there are a lot of what if analysis. So I'll tell you what is the role of AI ethicist is to make sure that they ask those product solution creators all those difficult questions, passing which only can solution make its way to the market. So everyone has well recognized that this can happen, and before it can happen. So basically, in self-driving cars, what happened is that you put it onto the road and it hits somebody, and then you say, okay, this is not working good, and let's go back. So you can't let those bad things happen and then you take action on them. So there are already a lot of teams who are working on it and making sure that these kind of products, which can lead to self-aware AI systems being pushed into the market. So the first is that's not going to happen, and that was the fear on which people were expecting that if it has to happen, then the entire use of AI, which we are making as of now, which is towards the betterment of humanity, it's all gone waste. These are the pros and cons of technology, the benefits that it comes with versus what worst can happen using this are being well learned, well discussed, and the organizations are working on it. So it's very far off from now. It's, I would say, slightly little hypothetical as of now, because the actions have been started taken place in the right direction in the right time.
Ma'am, so we can say that like it's kind of has the opinion has kind of been influenced by a lot of the sci-fi movies, I think. Also,
Okay.
they have played a very important role here, I'd say.
Yeah,
in this.
definitely. In fact, last year there was this movie about Michelle something, some English movie where they were showing a lot of robots and they are kind of putting all humans on a set of pods, not letting them act, and those robots have taken over the world and they are kind of
Yes, ma'am. Yes, ma'am.
controlled by AI assisted
Yes,
technology.
yes.
Because yeah, you remember, I think, yeah, that's the same thing. Yeah, so it's definitely, I would say, it's not entirely fiction. It was
Okay.
kind of somebody who would have foreseen that these can happen, because AI is the new thing. I would say
Yes.
even for the last 10-20 years, people are working on it aggressively.
Yes, ma'am.
But yeah, those fears is something which gets manifested in those ways, and yeah, that gives a common notion, so to say. And in fact,
Yes,
towards the end of
yes.
the movie, I remember I have seen they started giving how these two can be an ally. We can be an ally, the humans and the
Yes,
robots or
yes.
the machines. And it's just that pivotal point. So when you think it can be an ally versus when they are both, acting against each other, that is the point where that's the actually inflection point when the things have been put under control, I would say. So that, like I was giving the example in the cyber talk, right? The damage has done, and then you are trying to control it. It's like you're just trying to now protect your system in whatever state it has been left with, versus you're being prognostic and you have foreseen what might can go wrong, and then you kind of give a pause to that, taken a break, working on building your, I can say, guardrails before these things can go out of control.
Okay, ma'am. Thank you very much.
You're welcome. Are there any more questions? So, Professor, are we waiting for more questions?
We'll just wait for a minute.
Sure. Coding knowledge is mandatory for AI. So, okay, a question is little broad. I'll try to break it down into the granularity as much as needed, depending upon time. I hope you all are having few more minutes here. AI itself is like a lot of people work on it, and I can explain the life cycle. So you have a person whose ideation it is, that's the requirement coming from the business. Then there are product managers. You have a data analyst, data labelers, the solution architect, the one who designs the solution end to end, the person towards the model building side, then the inference side, the one who puts it into production, engineering team, and n number of people. So when we talk about AI, it could be an AI product effectively, right? So I'm not assuming we are just doing some research work in silos. So when you're working on the product, there's a pure teamwork. And in that team, lot many people come into the picture. So depending upon which role you are taking here, I assume that you're talking about the solution architect, which is what I've been doing. So if that is the rule, I would say that coding is definitely needed, because even if there are a lot of auto libraries which you can use and pull everything together for first cut, it definitely is not enough. You need to know the algorithms. You need to develop sometimes custom algorithms, maybe on top of what is existing and available through the open source libraries. And when you have to do that, you have to just not have enough coding language in knowledge. I would say you need to be very efficient at it, because once you're planning for your model to go into production, lot of parameters come into picture. Efficiency is just one of them. So even if you have somehow made your code work and your custom logic has been implemented, it's just too time consuming that your model, when it goes into the production, it hits the bottleneck, it's not efficient, the latency is too high, the throughput is not enough. You want to make sure that when you're working at scale in the real world, coding for this particular role in AI is definitely much needed, a must-have skill. On the other hand, it depends on which side you are. If you are not exactly a technical person, you may be a techno-functional. Coding requirement goes little less. You might not need to know all of it, the data structures and how you can write your algorithm with object-oriented framework and all. Depends, it goes down. And if you're totally towards the functional side, it depends on the interest. You can, I think, survive without that as well. Yeah, you're welcome.
I think there are no more further questions. Thank you, Vidhi, for accepting our invitation and delivering a much needed talk on AI and cybersecurity. Hope participants will explore more on this and they may work on something useful. Thank you.
Yeah, thank you, Professor. Thanks all. Thank you for making it interactive. Hope to see you all soon. Bye-bye.